Hello, my name is Madison Holloway, and I'm a biomedical engineering student at Mercer University. Today, I'll be presenting on the evaluation of filtration efficiency dependency on mask fit. As we know, mask mandates have been implemented pretty much worldwide now, and individuals are using facial coverings to go about their day-to-day lives, whether that be in the clinical sector or whether they're members of the general public. So my team selected different mask types to test our hypothesis that the fit would influence the mask's performance. And these were the N95 respirator, surgical masks, gaiters, and a triple layer cotton mask. Our experimental setup was that we had aerosolized NaCl solution flowing into a custom-built plexiglass chamber at a rate of 6 liters per minute via negative pressure. And inside this chamber, we had a mannequin head outfitted with tubing for airways. This tubing was connected to a wide-range particle spectrometer, or WPS, which collected data on the number and size of these particles that were allowed to pass through the masks. So the masks that I mentioned before would be applied to the mannequin's face with 3 different fit types: loose fit, tight fit, and perfect fit. And each of these had different parameters for what we considered to be its fit type. So for a loose fit, we would just hook the ear loops over the mannequin's ears, and we wouldn't pinch the nose bridge or alter the mask in any other way to affect the fit. For the tight fit, we would cinch the ear loops as tightly as possible, and we would pinch the nose piece if that was available. And then for the tight fit, we would apply double-sided tape around the mannequin's mouth in a rectangular shape, and then secure the mask to that double-sided tape. Before running any experiments with the masks, we wanted to validate our enclosure setup. So we ran 19 consecutive trials and analyzed the data to see if there was any significant difference between them. And there was not. So our enclosure would yield consistent data on the concentration of particles within the enclosure. So after we determined that our setup was valid, we moved on into the experiments with the masks. And as you can see in our data here, that under perfect fit conditions, the masks achieved their highest filtration efficiencies for each mask type. The data also showed that the triple layer cotton mask actually decreased in efficiency from loose fit to tight fit. And this was kind of interesting because we were expecting the opposite. One possible way that this could have happened is that during a tight fit, the area between the fabric for the mask was greater than during a loose fit. And so more particles were able to pass through the mask. Also, the neck gaiter had the lowest filtration efficiency overall for inhalation, and so it would protect the wearer much less than the other mask types. And one final thing that the data showed us was that the surgical and triple layer cotton masks actually achieved filtration efficiencies comparable to that of the N95 during perfect fit conditions. And we realized that perfect fit is not necessarily something that's achievable for everyone to get during a day-to-day basis. We're not recommending that you apply double-sided tape to your face. However, we do recommend that you try to achieve the best fit possible with your masks so there's not gaping on the sides. You want to make sure that it's nice and snug in order to make sure that the filtration efficiency is as high as possible to protect yourself and people around you. In the future, we would like to study source control. So this would entail figuring out how each mask performs at filtering particles from the wearer to the environment. So this would be kind of like an exhalation study. And we would also like to take a look at how social distancing and other factors affect the filtration efficiency of masks and being able to protect people. So that's all I have for today. Thank you so much, and I hope you have a good day.